Alright, so in this video I'll be demonstrating the actual functionality of the machine over here. And I'll first just kind of walk through generally how it works, how you interface between the GUI, which will be here on my computer, and the actual machine. And then later I'll show some actual cuts being made, because unfortunately I don't have enough hands to shoot this video and make the cuts at the same time. So after I've confirm that the power cables and I have a serial connection to my laptop and all that, I would just navigate to the folder containing the jar, click on it, and as you can see the program starts up and the GUI is now populated, so I can now start to interact with the machine. So you know, each piece is going to be different. Let's just say, for example's sake, I'm cutting a piece that has a 45-degree bevel in it. I can go over to the current angle text field here, type 45 in, press enter, and you can see that the cutter head here will move to 45 degrees. I can set the cutter head anywhere between 0 and 90, and you saw there was a bit of lag associated with that command, and that's just because the processor on my laptop is running much faster than the Arduino can process the commands coming from it. So I had to put some sleep statements, thread sleep statements in there to allow the Arduino to catch up. Next, I'm able to control the position. So let's just say, for example's sake, 45 here, and this will move the linear actuator. And that moves the linear actuator, as you can see, to a specific position of 45. That is associated with a specific length, which you'll see here in just a second. So the next sort of thing that I would do in the process here is I would go to my starting length, and let's just say I had pre-measured all my pieces that I was going to cut today, and I know they're all exactly 3 inches. Put 3 inches in. I have a target length for these, or this particular piece, of 2.125, which is 2 1/8. And at this point, you know, I've already set my angle, I've already set my position. I'm going to tell the machine that a cut's been made. Normally I'd go over here, make the actual cut, and then I have to tell the machine that that's occurred. So I'll press the hotkey C on my keyboard, and you can see that after that cut's been made, a couple of different things happen. Number one, the timer started over here, so I have the time being tracked for the piece that I'm making, and the current length text field has updated. So based on the position I'm at and the angle I'm at and the cut I just made, it's going to tell me, give or take about 1/100th, how long the piece is after I made the cut. So you can see if I started at 3, I moved to position 45 with angle 45. I end up with a piece that's 2.35 and, you know, etc. Inches long. Now we're shooting for 2 1/8, 2.125, so you can see that we're still short of our target, and the progress bar here is updated, and you can see that we're slowly starting to close in on that target. So let's just move to another position here. We'll just go 10 units up. Same thing will happen, the actuator will move. Just a small movement there since we're going from 45 to 55. I would at that point make another cut, and you can see same thing. We got a little bit more on the progress bar, and we're slowly closing in on that distance here. I obviously have sort of pre-calculated this for the sake of the video, and I know my target length should be right around 67 to get a perfect length piece. Same thing, another small movement on the actuator, tell the machine a cut's been made, and now we're right in that range, and you can see that the progress bar is essentially full, and at this point I would take the piece out and start to test fit it in the actual panel to see if it worked. So next step here would be to save the piece and begin making a new one. I just want you to note the elapsed time here. We're in the kind of between 100 and 110 range, so if I hit N, the hotkey here, that's going to reset everything, including the timer and the starting length text fields, and I can start to make another piece. At this point, I'm not going to actually make another piece because there's no point in demonstrating that functionality again. And I'll show you where that information's been saved in just a second, but I also want to demonstrate the error text field up here. So to prevent damage to the machine, just like based on the physical specs of how it is constructed, the cutter head, for example, can't go outside of the range 0 to 90 degrees. So if I tell it to go to 110, not allowed. And you can see, obviously, nothing has happened. Similarly, we can do the same thing over here. The range for the linear actuator is between 0 and 255. If I tell it to go to 300, no dice. And same thing will happen over here. If I try to edit the current length text field at any time, which is a text field that's populated only by the software, not by the user, it will tell me that I'm not allowed to do that. So just a couple of guardrails there to make sure that nothing breaks, the user doesn't break anything and make any mistakes while they're doing all this. So I'll go ahead and exit the program now, and I can navigate to the folder where the data for the piece would be stored. And you can remember I said to keep track of that that specific time. We were around 110, 120 seconds or something like that. If I open up the Excel file where all this is stored, piece number 8 was 112 seconds to complete. For this example, we started with a total material of 3, and I'm able to, as I go through and cut sometimes hundreds of these pieces, this Excel file will populate and grow, and I'm able to, at the end of the project, calculate the total time investment that I put into the panel and the total material if I were to ever sell these things in a commercial setting. So that's the basic functionality of the machine. I'll go ahead and just demonstrate the actual cutting functionality here just a second so you guys can see how that works. So this is the close-up shot of the actual cutting mechanism. Simple mechanism. This chisel is just held firmly against the cutter head surface and slid across manually like this to make the cut. Additionally, this back piece acts as a fence so you don't get tear out on the back of the wood here, like you can see in a piece that I cut without a fence. Get these kind of fuzzies. So these two metal plates here are coplanar, and the chisel just slides in between them. So I've already preset my angle of the cutter head and the position of the linear actuator. If I were to put my piece in there, it would line up right there. So we have just a small amount hanging over the edge here, and at that point I would just push my chisel through the cut, just like that. And you can see I had preset my angle to 75 for this particular one, and hopefully we can get some autofocus going here. Come on, camera. Hopefully you can see that that is cut at a slight angle there, 75 degrees in this instance.